This lecture is about software maintenance process models. Some process models covered in the literature are quick fix model, iterative enhancement model, full reuse model, IEEE 1219 model, ISO 12207 model. In the quick fix model shown, the source code and the necessary documentation are changed. Changes are made to the requirements, design, and code. The source code is compiled, and the system is tested. The quick fix model can be applied to all types of maintenance. The iterative enhancement model is an adaptation of the evolutionary development model to software maintenance. That is, the changes are based on the analysis of the current system. The requirements specification and design of the current system are modified and used as a basis for implementing the changes. This process is repeated for each batch of changes. The full reuse model differs from the iterative enhancement model in that it emphasizes reusing the existing system's requirements specification, design, implementation, test cases, and other reusable components from a repository. With this model, software reuse processes and techniques are applied to reap the benefits of reuse. The IEEE model is similar to the iterative enhancement model in that each stage of the development process is involved. The IEEE model has a problem identification classification process and analysis process, design, implementation, and regression testing, and delivery. The ISO 12207 model is similar to the iterative enhancement model in that each stage of the development process is involved. This model contains processes such as problem modification and analysis, modification, implementation, maintenance review acceptance, migration, and software retirement. To change a software system, the software engineer needs to understand the program. This is commonly referred to as program understanding or comprehension. It involves the process of extracting the design and specification artifacts from the code and represents them in a mental model. This process is the opposite of the development process, which begins with a problem statement and ends with the production of the software running in the target environment. Different mental models are used to represent the design and specification artifacts that are recovered from the code. These include object-oriented models, control flow models, and sophisticated models proposed by researchers. UML diagrams may serve as object-oriented models. Flowcharts and data flow diagrams are examples of control flow models and functional models. Software maintenance needs to identify the needed changes based on the change events. Sometimes more than one change is needed for a given event. All of these changes should be identified. It is worthwhile to identify alternative changes to accommodate a change event. For example, if it is costly or time-consuming to change a component and there are commercial off-the-shelf alternatives, then changing the component as well as using COTS should be identified as alternatives. This information allows the change analysis step to evaluate the options and select a viable option to pursue. Sometimes it is difficult to fix a component, to remove the root cause, but it is relatively easy to change a different component to fix the problem, at least temporarily. In this case, these two alternatives should be identified, and changes identified are analyzed to 1. Assess the change impact, that is, which other components will be affected by the changes made to a given component. 2. Estimate the cost and time required to implement the changes and test the result. 3. Identify risks and define solution measures. Changes made to a class may ripple throughout the system, affecting many classes. In practice, the classes are developed by different teams and team members. If Class A is changed and Class B is affected, then the developer of Class B needs to know that the class has been affected. Thus, changes to the components of a system must be made in a coordinated manner. Otherwise, the project would become chaotic. The mechanism to coordinate changes to components of a system is called software configuration management. Configuration change control, CCC, is one of the components. It performs two main functions. 1. Preparing and engineering change proposal. Based on the change analysis results, the maintenance personnel prepares an engineering change proposal, ECP. The ECP consists of administrative forms supporting technical and administrative materials that specify the proposed changes, reasons for the changes, the affected components, and the effort, time, and cost required to implement the changes. The priorities of the changes are specified, and a schedule to implement the changes is also described. 2. Implementing the change proposal. The engineering change proposal is reviewed by a configuration change control board, CCCB. The board consists of representatives from different parties, including representatives from the developers of the components that will be changed. If the review raises concerns, then the proposal is modified and resubmitted. In some cases, the proposal is rejected for various reasons. In this case, the proposal is archived for future reference.